to your monitor too, right?
Good. Yeah, we get it there. Hello, everybody. Hello. Oh, let me get the comments up
Yes.
live, right? So I pop this.
Yes, pop up. Sure.
Hang on, everybody. And then view cast. Look at that. Look at that. I remembered. Let the TV
It's not
show up, and then it doesn't show up. Wonderful.
That's awesome.
Oh no!
You just try again.
Computers. We got everything set up, ready to go, and the last piece doesn't work. Maybe I'll have you pull it up on your screen.
Yeah, no problem.
You can be my backup. That's funny.
Can you give me your link?
Sure. Hi, everybody. If you're joining, this is just funny. Let me send something to Travis here. There you go. Turn your volume off.
Okay, sure.
Well, hi, everybody. Here we go. All right. I think we're looking good. We are looking great. Hey, everyone. So, here we go. Another awesome week full of coding and stitching. And Mr. Griffin's totally insane. Oh, that's great, man. Totally insane wearable electronics class. I never thought when we start this class that we would end up here, right? This is nuts. So for those of you who are jumping in late, no worries. Hey, Travis, you can't move the goods. Oh, Mr. Travis is here, so I gotta give him a little guff. So today, what you are going to do is we are going to activate this microphone, so it actually turns these lights on and off. Now, I've been fiddling with my circuit so much that I've got one kind of kooky connection that's not any good. And it's right here. And you'll notice that as soon as I kind of pull this close, there's something that's just loose here. So instead of risking it and pulling the whole thing apart, like this whole, it goes into the number 6. So it's where the data is passing out. I thought, I could just resew it, and then I was like, well, I don't have enough time, and what if that doesn't work? So this does work. I just have to add just a little bit of tension. Hey, 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 yoo! So you can see that when this is tight, hey, 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 that the microphone input is turning these on and off. Okay, so that is today's goal. That's the first part. The second part of today's goal is that you modify the code to change the color of the lights. And that should be pretty easy. You've already done this in previous lessons, but it's good review, good chance to just remember what's going on. So I have sent you all the code by now. Yes. Should be in your inboxes, should be sitting there waiting for you. Go ahead and copy that code and put it into your whatever you're using to manage your code. For most of you, it's going to be CodeBender. Remember, use the link that I shared with you earlier in the semester. For some of you, it will be the actual Arduino IDE downloaded and installed from the Arduino company itself. I want to remind you guys that if you have any comments, feel free to type them in. We're on about a 60-second delay, so I've got it projected up here on my really big screen so I can see people checking in with me. Hello, Alex. Hello, Megan. Hello, Tim. Hey, Rex. All those people. Keep your eye out in the comments section. There are a couple people outside of the class who may surprise us today by dropping in. We'll see. We'll see if they're able to make it. So this will be exciting. Okay, so I trust that you hopefully have your code embedded. But let's just go line by line here a little bit, looking at this code to see what is happening here. It's kind of important that you know what this code is doing so that when you have to modify the code later on, you have some good guesses as to what's happening. Okay, so if you're still in your email, that's fine. You can look at the code there. If you've already moved it over to CodeBender or Arduino IDE, that's fine too, whatever. I'm in CodeBender, so that's just how I'm going to be looking at it today. All right, so let's go line by line here. Okay, so right at the top, we have this include Adafruit NeoPixel. This is the library. Remember, anytime we use these little round RGB lights, we have to include this library or else the Flora is confused and doesn't know what's attached to it. So always include that. The next thing here is that we are telling the board that we have 3 lights attached, and we're saying A9. This is where the microphone is attached. Travis, do you know why it needs to be A9 and not just 9? Oh, hi, Akari. Hey, Parker. Some more people dropping in. Do you know why? We don't know why. Nobody knows why, but it's A9, and it seems to work, so we're going to stick with that.
Because analog. So
oh, analog. He seems to think the A is for analog. Yeah. Do you remember from earlier discussions earlier in the semester the difference between analog and digital? This is going to come up today. Digital, remember, is just a 0 or a 1. Basically, it's off or it's on. That's it. But in this assignment, we need to do analog because analog is a scale of numbers, right? And so the microphone input, the numbers that are going in, are going to go from a low number all the way to a really high number when the volume gets loud, right? So analog deals with a scale and a range of numbers where digital is on and off. And depending on your project, depends on what kind of coding method you're using. Today, we're doing analog. Okay, LED pin 6. Remember, this is what we attached all of our lights to. We did this back in class together a few weeks ago. All right, so moving on down here. This is a really important line here because this is telling the code specifically what kind of lights we're using. This is working in conjunction with that NeoPixel library, so don't change anything there. Next down is that we're telling the board, hey, we could have up to 9 lights attached. We don't have 9 lights, we have 3 lights. And that's fine, this isn't going to change anything, but we're just alerting the board to the fact that there could be this many lights. Now, in a future lesson, when we add in up to 10 lights, remember I sent all those extra LEDs with you. Oh, Tim Rhodes said he accidentally sewed in all of his lights. Oh, that's okay, just leave them there. You're ahead of the game, Tim. Let's just hope that they all work. Eventually, we're going to have to change this code to include all 10 of those lights. All right, next we've got all 4 of the colors that we're defining here. Alex has probably already jumped in and mixed some of his own colors. If you want to do that, make some oranges and purples and whatnot, you can do that. Just add another line. You'll have to go to one of those LED RGB libraries online, look at the different color mixes for R, G, and B, and add those in. Okay, now we come down here to this int left a value. Oh my goodness, and we have a spelling mistake here, but I don't think that matters. We have the word value misspelled here, but you know what? It doesn't matter, so we're just going to leave it alone. Code doesn't matter if there's a spelling mistake, as long as the spelling mistake is throughout the entire bit of code. Sorry, I missed that one. That's okay.
And also, we don't need that one because we just delete that. So.
Oh, we can get rid of that line of code? We don't need it. Oh, that's right, because we eliminated that from the code.
And also...
So this actually doesn't make any difference. You know what? I'm just going to delete it.
No, you have to left this one. INT left. This one.
Oh, it's the value part.
Value and A this one part.
Okay, yeah, I'm just going to get rid of that. Hey, I forgot. We killed that part of the code earlier. Thank you, Travis.
You're welcome.
He's a good guy. He keeps me on the rails. Okay, moving on. Void setup. All right, so this is some of the things that the program needs to know before the loop gets created. And this strip begin and strip.show, this is dealing with a row of things that are all going through the same channel. Okay, so it's saying, hey, we're starting something, and then we're going to be displaying something out. And for lights, this is really important. Okay, the next one, this is interesting. This is the first time you've dealt with this. We're setting up something called a serial monitor in this lesson, and this is going to measure, it's going to give us an output of what the microphone is detecting. So we need to turn it on and make sure that the microphone is getting data. Koki or Alex says he thinks his mic is broken. Well, we're going to work on that. That's okay. We might be able to fix it by making some adjustments. But anyway, that's what this is for. I'm going to show you serial monitor in a minute. Okay, moving down. Now here's the actual loop. This is the thing that's happening when we run the program. We've got this analog read, right? Analog means a range of numbers. And we're getting this from the microphone pin, right? Because we're dealing with microphones. Down a couple more lines. If left, why we picked this word, I don't remember, is less than 20, then it's going to clear the lights, which means it's going to turn the lights off. It's not going to send any data to those lights, right?
Yes.
So what is the number that the microphone is detecting when my voice is going on? See how the lights are flashing on and off? Well, we're going to look at that in a minute. Otherwise, if the data being received by the microphone is greater than 20, aha, else, we'll look at this. Lights 0, 1, and 2, which are really lights 1, 2, and 3, are going to go to red. All right? And then we have to include this. We made this mistake. I think, Graham, you and I were looking at this and couldn't figure this out. But in order for the loop to successfully loop around, we have to clear the old data, right, in order to pick up new data to regenerate the loop. So these two lines are really important for clearing things out and starting the loop over again. All right, and that's it. That's the whole thing. So once you get this into your Flora board, man, I'm so happy with the way my circuit is working. I'm not even putting on any tension on that line. I just pulled it out a little bit, and the lights are happily flashing. This is great. Okay, so if it's going and things, or if your code is upload, but things are, maybe the lights are all totally on all the time, or maybe they're not flashing at all, and you're going, what on earth? Ah, this is crazy. Okay, well, let me show you a trick. It's called the serial monitor. So if you're in CodeBender, you go right here to serial monitor. If you are in the Arduino IDE, Travis, show me again.
Okay.
I think you go up to Tools, and then Serial Monitor. And for you guys, it's going to open up a secondary window, right? If we click that, where is it?
Yeah, because we didn't.
Oh, because nothing's connected to you. Okay, and a secondary monitor is going to show up. For us, look at this. When I turn on Serial Monitor in CodeBender, I get this extra window down here. Well, what is this for? Let me show you. So I'm going to click Connect. Look, see this 19,200, this baud rate? This is what we set up here, right? So I'm going to click Connect. And nothing's happening. Oh, there. Oh, hello.
Yeah, what's the connection?
Hey. There it goes. Okay, so you can see that these numbers, I think this is a little jittery because my laptop is dealing with a lot right now with multiple video feeds. But what you should see is a steady flow of numbers down here. When things are really quiet, the numbers will be really low. And then when things get really loud, the numbers should jump up. Oh dear, mine are not jumping. Here, let's disconnect. Let's try this again. I'm going to shut down the serial monitor and pull it back up again. And of course, this has been working great right up until now. Hey.
Test.
Hello. Hello. Okay, well, let me get to this in a minute. What you may not know is that on your microphone, there is a little adjustment that we can make right here on the mic itself. And some of you have asked me about this and didn't know what this was. Let me get this in focus, I think. See this little blue box? It's got this little cross piece in the middle. This is a sensitivity adjustment. So I've got a kind of a Phillips head screwdriver. And if I put it in there, I can turn it a total of, about 180 degrees in either direction. So if I turn it all the way to one way, hey, it's really hard to get the lights on to come on. So if I turn up the sensitivity, oh my goodness, and the lights are on. all the time. It's like every room noise, like even the fan of my computer is enough to make those lights go. Can you see that? Even in the silence of the room, there's enough noise coming through to turn these lights on. So I'm going to try to turn this to the point where it's about halfway. Hey, hey. Hey, hey.
Hey, you got some questions?
Oh, I'm getting up questions. Oh, hey, hey, hey. Woohoo, you. Okay, hang on. I think part of this is my connection is a little stinky. Hey. Check. Got it? So part of this is going to be measuring here. But stick your screwdriver in there and turn it back and forth and try to figure out kind of what the halfway point is. And then, as you yell into your microphone, be looking at your serial monitor. Maybe the numbers are floating around 40 when it's quiet in your room. Maybe your room is just louder. And if that's the case, then what you need to do is to go up here in your code. Where are you? I've lost my ability to scroll. And what you might need to do is to change this number right here. Because what you're saying is that anything under this value, the lights go off. But anything over that value, then all of your lights go on. So depending on your room, depending on the sensitivity of your microphone, you got to check that number. I think when we originally wrote the code, we had it set at like 50.
Yeah.
And I had to turn it down to about 20 seemed about right
so
for this
everyone's value
microphone.
is different because every microphone sensitivity is kind of
That's
different.
right. And your room is going to be different and how loud you can be. Maybe somebody's sleeping in your room and all you can do is whisper. Well, then adjust the microphone sensitivity, turn it way up, and then be looking at your serial monitor at the numbers to help you decide what is that threshold. For the lights are off, the lights go on, and then set that number in your left is greater than that number, and that will change. Okay, let me look up. We got some questions rolling in. Oh no, I can't see the code because of the quality. My Wi-Fi is so bad that the video is 144p. I'm sorry, Parker. Well, as soon as I'm done with this video, I'm going to render it, and then I'm going to post the video link, and so hopefully that will be better. I don't know. Maybe this is because I'm streaming. I'm not sure, but it should clean itself up, and you'll be able to see it in a minute. Oh, okay, here's one from William. Why are my numbers all in the thousands? Try turning the sensitivity of your microphone down.
Oh, maybe it's connection problem.
Alex, Koki, yours too. Travis is suggesting that this could be a connection problem. Like, what do you mean? Which connection? Like,
It didn't directly connect to the ports right here, so he must mention the connections. Make sure the connection is connected.
okay, so that's another thing to think about is to look at your connections between the floorboard and the microphone.
Yeah, because look, Alex always stay in the 1023, right? So that it should be connections problem. And he said he already got his working right now. So
Hey, Alex got his working. Okay, that's great. Fantastic. Okay, Akari, you said I'm confused about the serial monitor setup. I'm trying to remember which way. You were using the Arduino IDE, right? So with the Arduino, with your program open, you go up to Tools, and then you pick Serial Monitor from the drop-down. And that should open that second window, and then you'll see the numbers streaming. If your floorboard is plugged in and working, it's collecting that data and putting it in a stream right there. So you can see how sensitive the microphone is. I hope that helps. Oh, we have our first guest popping in. Do you know who Lynn Griffin is? It's my mom. I told you guys she might pop in, and here she is. Hi, Mom. Mom, are you following along with the students? I hope so. This is so cool. Okay, what else? All right, so what you need to do is adjust your code to make sure that the lights are flickering on and off. Adjust your microphone sensitivity settings. But another thing that you need to do, and I'm not going to help you with this, you need to figure this out, is to change the color of the lights to something other than red. Now you could change all the lights to be different colors, I don't know, or change them to be all purple or all orange. Doesn't matter to me, just change them from something other than red. Be careful with orange though. If you change them to orange, to my eye, when I check it, it might still look red. So pick something kind of far away from red so I know that you actually changed it. Oh my goodness, there's quite the side conversation going on in the chat room. You guys, stop talking to my mother. Come on now, focus. Hey, kids, here, look at me. All right, and what I need you to do is to shoot a very short video with audio, of course, that shows that your microphone and lights are responding. Now, if you have any questions about this, if things aren't working, Travis and I are standing by right now, and we would like to meet with you and help you with your code and your project, okay? So video call us, and we will talk to you and help you through. Are you ready, Travis, to take some calls?
Yes.
All right, I'm going to end this stream. This has been so much fun seeing you, hearing from you. I think I've answered all the questions up in the chat. Let me just have a couple minutes to shut this video down and post the link for those of you like Parker who maybe just need the raw video on YouTube. Okay? So I'm signing off. Good luck, everybody. Send me those videos. Send me those videos as soon as possible so I know that you're ready for the next step that we're going to take on Wednesday. See ya. Bye.
And